student. Today we are going to discuss about very important concept of physical properties of the drug molecule. In that, first property is the dielectric constant. So the study of physical properties involve the specific interaction between molecules and a well-defined form of energy or the external influence. So with respect to that, there are different type of physical properties that we need to study, like dipole moment, optical rotation, dielectric constant, refractive index, surface tension, viscosity. So with that concern, today we will discuss about very important physical property called as dielectric constant. So the content of this presentation, we will discuss about introduction to the dielectric constant, what is the dielectric constant, how to measure the dielectric constant, and what are the applications of a dielectric constant. So dielectric constant is a physical property that is influenced by the interatomic and intermolecular attraction. A polar molecule can sustain a separation of electric charge either through the induced by an external electric field or by a permanent charge separation within the molecule. The separation of charge can be best understood from the concept called as dielectric constant. So we will consider the example of a parallel plate condenser. So condenser is one that can store the energy. A simple condenser consists of two parallel plates separated by insulating medium. If a potential difference is applied, if we apply the potential difference across the plate, electricity will be stored depending upon the nature of the medium. So this is the diagrammatic representation of a condenser having two plates and which are connected with the source of energy, that is electricity, and we apply the potential difference across the plate. So whatever the liquid or the material for which we have to determine the electric constant, so depending upon the charge present on that material, there is a separation of a charge to the oppositely charged plates. So positive will move towards the negative and negative will move towards the positive. So there is a polarization of the molecules. So parallel plates are separated by some medium across the distance, what we call it as R, and connected to the voltage supply source. Electricity will flow across the plate from left to right through a battery until potential difference of the plate equals that of the battery, which supply the initial potential difference. The capacitance C is equal to the amount of electric charge, which is indicated by the Q, stored on the plates and divided by the potential difference, which is indicated by the V. So we will get the equation capacitance C is equal to Q upon V. So the capacitance of the condenser depends on the types of a thickness of the condenser separating plate. C0 is used as a capacitance reference medium on which to be compared. to the other. C0 is the capacitance between the plate when vacuum fills the space between the plates. The ratio of the capacitance of the test Cx divided by the capacitance of the reference material is termed as a dielectric constant. So we can write epsilon, that is E, is equal to Cx upon C0, where epsilon is the dielectric constant. Since it is the ratio of capacitance, so dielectric constant is a quantity or unitless quantity. So polarity of the solvent depends upon the dielectric constant. As more is it polar solvent, greater will be the dielectric constant. Therefore, dielectric constant of the substance affect solubility of that substance in a different kind of solvent. As we know, most of the drugs are non-polar, semi-polar. So there is a universal saying that like dissolve like. That means polar solute will be dissolved in a polar solvent, non-polar solute will be dissolved in a non-polar solvent. So this dielectric constant is a physical parameter for the liquid which will help us a selection of a solvent for the solubilization of the drug. So here are few dielectric constant of the liquids like acetone having 21.4, formaldehyde 22, benzene 2.28, hexane 5, carbon tetrachloride 2.24, glycol 50, chloroform 4.8, methanol 33.7, and others are given on the slides. As far as the application of dielectric constant is concerned, dielectric constant is a physical property that can be used to determine the nature of the solvent, whether it is polar, non-polar or semi-polar, can be determined, can be scaled upon the dielectric constant of that solvent. It also helps in the selection of the solvent, which type of solvents to be selected, which gives the maximum solubility. So dielectric constant is used, and we can also select the blend of a solvent to get maximum solubility. Again, this dielectric constant is used and having a application in radar to find out the buried object and the nature of buried object. So these all are the applications of a dielectric constant. I hope you got the small concept of a dielectric constant, which is important physical property. So stay tuned and keep learning. Thank you very much.